Well, hello and welcome to this NASA Earthdata webinar titled Subsetting and Reformatting Data from the NASA Earthdata Cloud Using Harmony Pi. Thank you for being here today. Just a few words before we begin. As you might have already noticed, the chat is open, so feel free to engage with your fellow attendees during this event. If you're going to interact with others, we ask that you do so in a respectful and professional manner. Next, AI bots like note-taking tools are not permitted in NASA meetings. If any are detected, we'll be booting those from this meeting. And that brings me to my next point. The recording of today's webinar will be publicly available in a couple days. You'll be able to find that on the Earthdata website and watch your inbox too, because you'll probably receive the link to the video there as well. And finally, there will not be a Q&A session today. This is a short presentation, and we're maximizing today's time for the presentation itself. So with that being said, I'm happy to turn things over to Diane.
Thanks, Jason. I do want to let people know that in the chat, there are some people that can answer your questions. And so do feel free to ask questions in there as we go along. All right. So I'm here to tell you about Harmony Pi and how you can use this Python library for subsetting and reformatting data from the NASA Earthdata Cloud. So what is Harmony and what does Harmony do? So it is a transformation service that allows you to do spatial subsetting, temporal subsetting, variable subsetting, reprojecting, and even reformatting on particular data sets. So this service is not enabled equally across all data sets. We need to find out what services are available for each one. But I am going to show you how to do that. So Harmony works on these data sets through NASA's Earthdata GUI search as well as a API. But today we're going to look at a Python library that lets you do that. So the example we're going to go through in a Jupyter Python notebook is looking at SMAP soil moisture. So this particular data set has 52 variables, each for AM and PM. It has a lot of different days of coverage, obviously, and here's a screenshot showing a day of coverage over the globe. But also maybe you don't want a whole globe, you just want a particular day, and maybe you just want to spatially subset to, say, just the eastern coast of the US. So I'm going to step through doing that with this particular data set in Harmony Pi. So just to get a little bit of clarity about what this subsetting in Harmony is, when we take a bounding box for a spatial subset, a lot of times you'll use it for filtering and you'll be able to grab every kind of data set that crosses that bounding box. But what Harmony is actually doing is chopping your data to that bounding box area of interest. So this is an example with the state of Colorado. And I just wanted to be clear that Harmony is doing a spatial subset cut for you, not just a selection. All right, so for the demo I'm about to go through, there is a notebook location that you can go back and look at this later and poke at. So if you're not following me along right now, you can do so later. There's also Harmony Pi documentation that you can dig in and read those docs, so that resource is here. And as always with NASA Earthdata, it's freely available to all, but you need to have an Earthdata login to be able to authenticate in. And so to create that Earthdata login, here is a URL to do so. And we'll show you in the Harmony Pi library how you authenticate with your credentials once you create them. So there's some prerequisites for this notebook to work. You need to have an environment that has Harmony Pi installed in it. You need Python 3.9 or higher. That's the dependency for this library. And as I just mentioned, you need an Earthdata login to actually be able to access the data. Also recommended is a GitHub account, so you can go and pull that notebook copy, and we're going to be working in Jupyter. So with that, I'm going to hop over to my notebook, and I have some descriptions here, so you'll be able to look at that too when you go and look at the notebook. But what we're going to do today is we're going to import packages that are appropriate for this notebook. We're going to authenticate in with that Earthdata login and initialize a Harmony client. Then we're going to define and explore a data set. It can be anyone, but we're going to work with that SMAP data set today and look for the soil moisture variable within it. And then finding what kind of services Harmony has for this data set, then we're going to build a request, submit that request, and then download and plot our data. All right, so I've already pre-typed out the packages, but I'm going to go ahead and run this cell. So get pass is just something so I can hide my password when I'm coming in. We're going to be using a JSON display to be able to understand our Harmony services that we have available more easily, because it comes out as this big long JSON string. We're going to use datetime for doing a temporal subset, and then use raster IO to plot it. But here's the important one from Harmony. We're going to be using the bounding box and client collection request and capabilities request functions in there, and I'll show you how to do all of that. So I mentioned Earthdata login. What I am going to do is create a authorization here with these two variables that I'm just setting an input for my Earthdata login, my username, and my password. And so when I run this, it's going to prompt me for, sorry, I have a heavy finger. I dragged my finger somewhere it didn't need to be. And now it's going to ask me for my password. And if those credentials don't go through, you'll see some kind of error pop up. And so then the next thing, I've have my Harmony client created with that authorization. Now I'm going to try and pull my data set and figure out what is available for it. You can do this with a dataset short name or the concept ID. There's a how-to for being able to find concept IDs, which are useful because they're version specific. But today we're just going to use this short name for our dataset short name. Very obvious variable name right there. And so now to actually discover what is available for this, what I need to do is create a capabilities request. For this particular data set. So I'm going to put that variable in there, and I'm using that Harmony function for a capabilities request. And then I'm going to submit that to my Harmony client. And now here's where I'm going to use that JSON display. And this is great because here we're looking at our soil, our SMAP level 3 radiometer global daily data set. And when I look at the capabilities of this, so I can see there's my concept ID, my short name, and I can see that for this data set, I can do bounding box subset. I can do a variable subset and temporal subset. Here, it also is going to give me all of these variables. There's 104 available in this data set. So this is a really nice way to display what is available as transformation services with your data set of interest. So now that we know what is available, we can come down and build a request that has these spatial subsetting for spatial, temporal, and variable subsetting, as well as a reformatting option. So now this is creating the request. And we want to have our variable for our data. We need to tell Harmony which one we are looking for. And now I can enter in things like a spatial request. And so I already have in my mind actually written on the side over here in a little cheat sheet the west and south and east. This is the order of the latitude and longitudes that we type things in. It's that Wesen, W-S-E-N. So I'm going to enter my bounding box. This is the one that is that east coast. And then I am going to put in we'll see if this works. To be fair, if it doesn't, I have we'll hop somewhere else. But our temporal constraint for this is kind of turned in with a start and stop time. And so we're going to look for that December 12th. And using date time to be able to put that temporal constraint on. And we're going to go from December 12th to December 13th. And this is going to give us two different granules returned. So in addition to these subsetting, I've done a spatial and temporal. Now I can do a variable subsetting. And for this, I'm going to go back up here to my variable so I can just copy and paste. It's good to be familiar a bit with what your data set is. So I happen to know the soil moisture is down at 26, but I can look and see, okay, this one has albedo as well. But if I want to get the exact group and the variable name, I can just copy and paste it from that area and explore also what is available in my data set that way. And now, after all of that subsetting, I'm going to say I also want to have a geotiff returned. So I can say I want to have my format be a TIFF. And so that is the request that I'm going to, data time, that's a good one. I don't know how many people always just type data when they're trying to type date. This happens to me a lot. All right. So now we've created the request. And now I am going to submit, and the same as with that capabilities request, I'm going to submit this request. And now here's where things hopefully will work. If not, I will hop to a different notebook. Yay. All right. So now if we are looking to see how our job is processing, you can see if you look for wait for processing and just kind of see what your progress is, this is a really nice way to just make sure that Harmony is receiving this request. The job ID is something that helps us keep track of what we're putting into NASA's Earthdata Cloud. And this URL here is something I'll show you a bit later. If you go to your workflow UI, this is particular to you with your Earthdata login, so you have to be logged in. But then it shows you all of your job IDs that you have. And if I print my job ID, you can see it and track it and know exactly what's going on. And if something fails, it's a really good place to go to and see logs of, what was going on? And I'll show you an example of that. But so now Harmony has these URLs where there is staged data. And so we have two different granules in this, and you can see these different places where Harmony has looked at your request, has staged this, and then you can go down and say to that Harmony client, now that they're sitting there, they're there for 30 days, so you don't have to jump on it right away. They do stay in the staging area. And I'm going to download to this local directory right here, but you're also welcome to change this to any place that you want to have your data go to. And so in just a moment, we're going to see them pop up over here inside my local directory. There they are. And now we can work with that data. So I'm just going to do a really simple plot with them right away. And there we have it. We have that eastern coast. You can see the Great Lakes kind of sitting in there. And then this is the other granule that was in the AM/PM pair. So I want to jump over to my workflow ID and let's see. Let me take these off for a second because that was kind of a preview. This is the job that we just ran. And so if you go to that workflow, you can see what Harmony's doing. It says it's successful, and we were able to plot that data and look at it. Here, if I go down to a different kind of job, I just wanted to show you something where things were a little bit different than pure successful. Sometimes you can see warnings and saying, there was no data in my request. And so you can kind of get feedback and then see logs of what's happening. So with that, I just want to close with saying that the Harmony Pi development team is out there and they welcome feedback with GitHub issues. So you can go and give feedback about how things are working. And then in the future, we have a project where people are working on getting Harmony into Earth Access, another great Python library you might have heard of, as a plugin. So all of this functionality will be in one great place.
Excellent. Thank you. Of course, we want to give a big thank you to Diane for walking through that with us today. And if you'd like to share any feedback with us, earthdata-support@nasa.gov is how to do that. And thanks to everybody who attended live today. Again, the recording of this event will be publicly available soon, and you'll be able to find that on the Earthdata website. And while you're there, be sure to check out all of our upcoming webinars and other freely available learning resources. We hope you join us again soon for another NASA Earthdata webinar.